Hello everybody, my name is Prakash Adhikari, DBA student at California Intercontinental University. Today I am going to make the presentation about the correlation test using PSPP software and the result analysis. Let's talk about the agenda. This is pretty simple. Just we'll come to know importing given survey data sets in PSPP. Then we'll conduct correlation analysis test using PSPP for the given set of the variables. And we'll be stating hypothesis test, and definitely we'll talk about the rejection rule as well. We'll talk about a scatter diagram, and we'll analyze the result from the test, and we'll be deriving the conclusions. For this analysis, we'll be using the same dataset, GRC605 survey dataset, and this includes different financial variables like income, debt, savings, stocks, etc. You can see other variables here. Then now let's come to how to use PSPP for the correlation analysis. As we all know, PSPP is the robust software for the statistical analysis. Let's talk about the correlation test procedure. First of all, we need to import the dataset in PSPP in proper format. Then we'll go to the toolbar and we click Analyze and select Bivariate Correlation. Then one dialog box comes there, and select the variables for the test. If you're doing the correlation test between debt and income, select these two. Then click OK for the test. Then you will see the results. Here altogether 10 set of variables we are using for the correlation test. Out of those, we'll be getting 4 statistically insignificant, and 6 of those data set which are in black letters will be statistically significant. Those in red will be statistically insignificant. Now let's talk about the rejection rule. Like in all kind of the hypothesis testing, even in the correlation based hypothesis testing also, we need to define the rejection rule. Here we'll calculate the p-value like in other tests as well. If p-value is less than equal to level of significance, that is alpha, which is as a standard considered as 0.05. If p-value is less than equal to alpha, then reject the null hypothesis, and obviously we'll be accepting the alternative hypothesis. Now let us conduct the correlation test for the variable income and debt. Let's go here how we set up the null hypothesis and alternative hypothesis. In correlation test, the null hypothesis will be there is no correlation between the income and debt of the participants. That is, the correlation coefficient will be 0. And alternative hypothesis will be there is a correlation between the income and debt of the participants in US dollar. Hence R is not equal to 0. We all know that R oscillates from -1 to +1. And if we look at the test result here in the table, we can see R is equal to -0.05 and P is equal to 0.535. Here the value of the P, the calculated value of P, is way higher than the level of significance, that is alpha is equal to 0.05. Hence the test is statistically insignificant. The correlation between income and debt is very weak. Statistically we can say that there doesn't exist the correlation between these two. Likewise, let's see the test result for income and savings. So null hypothesis will be there is no correlation between the income and savings of the participants in US dollar, and the alternative hypothesis will be there is a correlation between the income and saving of the participants. And if we look at here, the R value is 0.91, very strong, closer to 1, means there is a very strong relationship between income and saving. And p-value is equal to 0, this is less than level of significance alpha 0.05. Hence the test rejected the null hypothesis and concluded that there was a correlation between the income and saving of the participants in US dollar. And this way of the presentation follows the APA style of the result presentation. And similarly we conduct the now let's see the scatter plot, and you can use the PSPP for the scatter plot diagram. Just go to the graphs and you will see the scatter plot diagram there. And in this case, let's say income and saving. Let's see how their relationship is depicted in the graphical form. If you do that, you can see this graph here. If you look at income versus saving, as the income goes on increasing, saving also increasing, and vice versa. Means they have a very strong relationship. You can put the average line there, that will be straight line, means they have a very strong relationship. So scatter plot diagram graphically shows the strength of the relationship between two variables. Likewise, let's go for the income and stocks. We carry out the test with the same model, null hypothesis. There is no correlation between the income and stocks of the participants. Then the alternative hypothesis will be there is a correlation between income and stocks of the participants. And here P is equal to 0.018 and R is equal to 0.19. P value is less than 0.05. Hence the test is statistically significant. There is a correlation between the income and stocks of the participant in US dollar. Most likely when there is higher income, then people will have surplus and they might invest in the stock, so their portfolio value will be higher. So these two are related. Likewise, let's go for the income and wallet. This test are also statistically significant. R value is equal to 1, very strong. If you have higher income, higher cash, of course. And P is equal to 0. The calculated value, P value is 0, means it's less than alpha 0.05. Hence the test is statistically significant. There is a strong correlation between income and wallet. Likewise, now let's go for the debt and saving. This test shows statistically insignificant. You can see here P value is way higher than 0.05. P value here is 0.748. You can see on the table. So there is no correlation between the debt and saving of the participants. Now let's go to another variable set, debt and wallet. And here P value is 0.533, that is way higher than alpha 0.05. Hence the test is statistically insignificant. So we could not reject the null hypothesis that there is no correlation between the debt and wallet of the participants. Now let's see the test result for saving and stocks. If you look at P value, that is 0, which is less than level of significance, alpha that is 0.05, and R is 0.28. There is a strong relationship between the saving and stocks. And as the P value is less than alpha, the test is statistically significant, means there is a correlation between the saving and stocks of the participants in US dollar. Yeah, this is quite obvious. When people have saving extra surplus, they invest in stocks to magnify their wealth. Likewise, in savings and wallet, no wonder the R value here is 0.91 and P is equal to 0. Test is statistically significant, means higher the savings, there will be more cash in the wallet. Likewise, stocks and wallet. When there is more cash, people might uh, invest in stocks to magnify their money. So here the test result is P is equal to 0.017 less than alpha 0.05. So test is statistically significant and R value is 0.19. Hence there was a correlation between the stocks and wallet of the participants in US dollar. Now we carried out all the statistical tests, and out of the 10 variables data sets, we found 6 are statistically significant and 4 are statistically insignificant. So now let's talk about what we get from overall this presentation. Of course, we came to know how to use PSPP for the correlation based hypothesis testing and analysis. Now we can find the p-value and r, and we can interpret these values for the decision making. Likewise, we learned about the APA style of results write-offs for the significant and insignificant correlation, and we also saw the graphical depiction of the correlation between two variables by a scatter diagram. That is, this is very useful graph which gives the insights about the strength of the relationship between two variables. So this is all about my presentation. Thank you for your attentive participations. If you have any questions, please feel free to ask me. Thank you.